Hi, hello students, good evening everyone. I hope all are doing well. Anyway, welcome back all of you to Infinity Learn JEE YouTube channel by Sri Chaitanya. This is me Surya, your chemistry faculty from Infinity Learn. Okay, if anyone is watching this particular live, just give me a hi in the comments. Okay, today in this particular session, we are moving to the next part of hydrocarbons. That is about the second type of hydrocarbons, right? Alkenes, that is the chemical and physical properties. Let us quickly start the topic now. Before that, I will give a brief idea about the last topic we have covered in the last class. It is about the preparation of alkenes. As you can see over here, these are the methods to prepare the alkenes. First one, it is from the alkynes, right? Unsaturated hydrocarbons. We can use two types of different catalysts, right? Two types of different catalysts to find out the alkenes here. As you can see over here, if you are using hydrogen in palladium, right? This is our Lindglas catalyst. If you are using Lindglas catalyst in process of alkynes, you will get the cis alkenes. Okay, this will be our cis alkenes. Then instead of Lindglas catalyst, if you are using sodium in liquid ammonia, right? Hi Rana, good evening. Okay, fine. So here, if you are using sodium in liquid ammonia, we will get the trans isomer, right? Trans isomer, which is we have already covered in the last class. So I am going very fast. The next method is the dehydrohalogenation, right? In case of hydrogen halide, we are trying to remove the hydrogen halide, right? This method is known as the dehydrohalogenation. One of the important rule we are using here, it is Zaitsev rule. I hope it was very clear. Yes, transalkene means sodium in liquid ammonia, right? So here Zaitsev rule is very important because Zaitsev rule states that if you are taking hydrogen from the less number carbon, right? Less number carbon here. So this is a Zaitsev rule about the dehydrohalogenation. Okay, fine. Hi. Then the next method it is about the dehydration, right? Dehydration of alcohol. Same as according to the Zaitsev rule, you can get the two products. Major product will be according to the Zaitsev rule here, right? Here the reagent used is concentrated sulfuric acid. Clear? I hope it was clear. Then the last method of preparation is from the vicinal dihalides, right? Vicinal dihalides means if two halogen groups are present to the adjacent carbon atoms, right? Yes, adjacent carbon atoms. These are known as vicinal dihalides. If you are doing the dehalogenation, right? Dehalogenation means removal of halogens, right? Removal of halogens from the vicinal dihalides, you will get alkenes in presence of zinc metal. Then one more, yes, here. One more thing you have to remember about the Hofmann rule, right? If you are taking bulky group base, right? Bulky group base, if you are taking instead of Zaitsev product, you will get the Hofmann product, just opposed to the Zaitsev rule. I hope it is clear. Yes, geminal means two halogens on the same carbon, right? You are revising, right, Prashant Soni? Now let's directly talk about the physical properties of alkenes. As you have seen about the alkenes also, right? So we have to study about the solubility, physical state as well as physical properties, right? About boiling point and, yes, boiling point and melting point here. So here we can already see that there will be different members, right? If you are taking the first three members, what are the first three members in the alkene group? Okay, you have already done the hydrocarbons, right? Great. So just now you are revising, right? Okay, alcohol, phenol and ether, yeah. More name reactions are there, right? Once you complete the topic, just keep on revising. This is a better trick to learn the organic chemistry. So here, what are the three different groups? Three different members. First three members of the alkenes group. Okay, ethene, propene and butane, right? 2 carbon, 3 carbon and 4 carbon compound. These compounds are generally gases, right? Generally gases. Then if you are taking other gases, right? If you are It's about alkenes, not about alkynes, right? It will be butene, propene. Suffix will be ene. Very important. So if you are taking all other alkenes except these three we can say that it will be odorless and colorless. It should be odorless and colorless. Then about the solubility, right? As we have already seen about the alkenes also, there will be soluble, right? Yeah, it's fine. Okay, here in case of alkenes, they are non-polar in nature, right? Non-polar in nature, so they will be dissolving in the non-polar solvent only. Here it will be insoluble in water. Should be insoluble in water. Then, as according to alkenes, alkenes are volatile, right? Then, if you are talking about the boiling point and melting point, just like alkenes also, in case alkenes also, if you are increasing the molecular size, right? If you are increasing the molecular size, boiling point increases here because of the strong van der Waals force. Okay, I hope it is clear. It's about the physical properties of alkenes. You must have an idea about the physical properties of alkenes. Now let me move to the next topic, that is about the chemical properties of alkenes. Chemical properties of alkenes. As we already know, in case of alkenes, there will be a double bond, right? One should be a strong sigma bond and another will be a pi bond, weak pi bond. So, in order due to the presence of these pi electrons, there will be the addition reactions happens, right? There will be easily attacked by the electrophilic reagent. I hope everyone have the idea about the electrophiles and nucleophiles. So, there will be electrophilic addition reactions happens in the case of alkene. So, we need to study about the different types of addition reactions in the case of alkenes. So, starting from the addition, we will be moving to the oxidation, ozonolysis and last one, polymerization. Okay, let us start about the addition reactions, right? First method, it is about the addition of hydrogen. As we already seen about the preparation of alkenes, right? If you are taking any of the unsaturated compound, we need to add hydrogen, right? We need to add hydrogen in presence of which catalyst? There are three catalysts are used, right? Yes, nickel, platinum and palladium, right? Yes, correct. Nickel, platinum or palladium. If you are using nickel, platinum or palladium catalyst, if you are adding hydrogen in presence of any of the unsaturated hydrocarbons like alkene or alkyne, we will get the alkene, right? Single carbon compound. Yes, correct. So this is known as the addition of hydrogen. Otherwise, this is known as catalytic hydrogenation. Catalytic hydrogenation. Right? So, if I am taking propene here, right? What will be the product? What will be the product? Give me the name of that particular product. This bond breaks, two hydrogen comes here, right? So product will be CH3, CH2, CH3, that is our propane, right? Yes, correct. It will be propane. So this is an important method which is used for the preparation of alkenes as well as chemical properties of alkenes. I hope it is clear. Now let me move to the next type of addition reaction, that is addition of halogens. Yes, addition of halogens, right? Instead of hydrogen, we are adding halogens here. Any of fluorine, chlorine, bromine or iodine, right? In general, we are doing the chlorination, bromination and iodination. Yes, in addition, right? Okay, here halogens, especially chlorine and bromine, add on to the alkenes at ordinary temperature to form vicinal dihalides, right? Vicinal dihalides, which means I have already mentioned two halogen atoms present on the adjacent carbon atoms. These are known as vicinal dihalides. So here I am taking CH2 double bond CH2, our ethene molecule, right? This is our ethene molecule. I am adding bromine in presence of CCl4. There I am using a polar solvent here. CCl4 polar solvent here. So what I am observing here, I will get the dibromide, right? Dibromide, vicinal dibromide here. So here, if you are doing the chemical experiment in the laboratory, you can see that in the first reaction, right? If I am doing the first reaction, if I am adding bromine in CCl4, it is have a reddish brown precipitate color, right? It will have a reddish brown color. Okay, in general, bromine and CCl4 having the reddish brown color. After doing this particular reaction, if I am taking ethene molecule, then I am adding bromine and CCl4. What I am observing that this brown color, right, this reddish brown color disappears. Because these double bond compound react with bromine to form vicinal dibromide. So we can use this method as the test for unsaturation. If any of the compound that is containing multiple bond, right, like double bond or triple bond, we can use this particular reaction to test whether it is containing unsaturated compound. So this method is known as test for unsaturation, right? Test for unsaturation. Okay, is that clear? So this general method is known as the halogenation, right? We are adding halogens. So this is known as the halogenation. Instead of bromine, we can use chlorine also, right? Chlorine as a halogen. Then iodine also. If you are considering the order of reactivity, we can say that chlorine is having maximum reactivity than bromine, then iodine, right? Okay, I hope it is clear. Now let me move to the next addition reaction. It is about the addition of, okay, one more thing you have to be noted in case of halogenation. Hi Anusri, good evening. Okay, one more thing you have to be remember about here, it is about the stereochemistry, right? So this is our alkene. You have to mention whether it is cis alkene or trans alkene. Cis alkene or trans alkene. Cis alkene, right? Because this is a cis alkene, as you can observe here. If you are considering these hydrogen atoms only, these hydrogen atoms are on the same side of the double bond, which means that they are cis alkenes. So if I am adding bromine in presence of CCl4, right, in presence of CCl4 to the cis alkene, what I am observing that I will get two different products, right? I will get two different products. I hope you must have idea about the stereochemistry. This is our D form and this is the L form. It is about the optical rotation. So it is observing that the D and L product is getting in 50% each, right? 50% each. So this particular mixture is known as racemic mixture. Racemic mixture. So here the important point you have to be keep in mind that if you are doing the anti-addition, right? This is the anti-addition method. If you are doing the anti-addition of cis alkene having anti-addition, you will get the racemic mixture, right? You will get the racemic mixture. C stands for cis alkene. Here A means anti-addition, right? These halogenation reactions are generally anti-addition. It will get the racemic mixture, right? Then one more point, one more question is that if you are taking trans alkene, what will be the product? If you are taking trans alkene, what will be the product, right? Same, I am doing the bromination in presence of CCl4. This is my trans alkene, right? If you are observing hydrogen, these are on the opposite side of the double bond. So this will be the trans alkene, right? This will be the trans alkene. Okay, this will be the trans alkene. So what I am observing here, this is the mesoform, right? Mesoform means if you are having achiral centers, right? If you are considering these compounds, I can say that there will not be any optically active centers. So this will be our mesoform. This is the meso 3,4 dibromobutane, right? Okay, similarly you can do it like this. Anti-addition of trans alkene gives mesoform. Clear? Here A stands for the anti-addition, T stands for the trans alkene, M stands for the mesoform. Now let us talk about the next type of addition reaction. That is about the addition of hydrogen halides, right? Addition of hydrogen halides. For example, if I am taking any of the symmetrical alkenes, we can again divide the alkenes into two types. It will be symmetrical as well as unsymmetrical alkenes. If you are considering any of the alkenes in which similar groups are attached to the double bond, we can call it as a symmetrical alkene. For example, I am taking ethene molecule, right? This is our C double bond C. To the double bond, there will be two identical hydrogen atoms are present. So I can call it as a symmetrical alkenes. In case of symmetrical alkenes, if I am adding hydrogen halide, for example, I am taking HBr, right? Hydrogen bromide. What I am observing, I will get CH3CH2Br, right? CH3CH2Br, right? I will get the alkyl halide here. The second case, if I am taking unsymmetrical alkenes, right? If I am taking unsymmetrical, yes, Markovnikov as well as anti-Markovnikov, right? Okay. If I am taking unsymmetrical alkenes, for example, this one, right? This is my propene molecule. If I am adding propene, if I am adding HBr, same hydrogen bromide to the propene molecule, I will get two different products, right? I will get two different products. While experiment, it is observing that this 1 bromopropane is obtained as 10%. It is as a minor product, right? But the 2 bromopropane is obtained as 99% as the major product. What will be the reason behind that? So here we are introducing the Markovnikov's rule, right? Markovnikov's rule. It states that the negative part of the addendum means if you are adding molecule. Here we are adding HBr molecule, right? We can divide this or break this HBr as H plus and Br minus, right? H plus and Br minus. According to Markovnikov rule, it states that the negative part of the adding molecule or the addentum, that is Br minus, will goes to the carbon that is containing less number of hydrogen atoms, which is containing less number of hydrogen atoms. Right? For here, Br minus, right? Br minus will go to the carbon, double bonded carbon containing less number of hydrogen atom. This will be our second carbon, right? So it will form as CH3, CHBr, CH3, which means 2-bromopropane will be our major product. Is that clear? Just let me know in the comments, is that clear? Okay, similarly you can add HCl and HI also instead of HBr. In general, these reactions happens in dark condition. Yes. Now, the next method, right? Next method, I am taking the same unsymmetrical alkene, but what I am observing here? Okay, what I am observing here, in the case of HBr, I am adding HBr in presence of peroxide, right? I am adding HBr in presence of peroxide. What we are observing? Instead of that product, I will get another product, right? It is based on the anti-Markovnikov's rule. This rule was proposed by Karash. Therefore, this effect is also known as Karash effect, which is against our Markovnikov's rule, right? So, it is again known as anti-Markovnikov rule or peroxide effect. In presence of peroxide, it is happening. But it is observing here negative part, right? Br will go to the double bonded carbon that is containing more number of hydrogens. So, we will get the product as CH3, CH2, CH2, Br. 1-bromopropane will be the product, right? Yes. In case of peroxide effect, you have to remember that it will happen only with the HBr, right? It will happen only with the HBr, not about HCl and HI. What will be the reason? Anyone? Okay, before that, I have to give you the idea about the mechanism of Markovnikov's rule. As you can see over here, right? This is our alkene molecule. This is the HBr. From the HBr, we will get the H plus ion. This H plus ion will react with it to form a carbocation. I hope you must have the idea about the reaction intermediates, about free radicals, carbocation and carbanion. Here, this reaction is based on the carbocation mechanism, right? Carbocation mechanism. Okay, I will not go deep into the mechanism here. It will be given in your NCERT textbook. Just go through it. Okay, carbocation mechanism. While forming here, you will get two types of carbocation, right? As you can see over here. If it is observing here, it will get the plus on this carbon, right? So, this will be our primary carbocation, which means that this particular carbon is attached to only one carbon atom. So, this will be the primary carbocation. Then the second possibility is that it will be forming secondary carbocation, right? It will be forming secondary carbocation. So, here it is observing that this carbon is connected to two other carbon atoms. So, it is known as secondary carbocation. So, according to the stability of carbocation, we can say that tertiary carbocation is more stable than the tertiary carbocation is more stable than secondary than the primary. So, if you are taking primary and secondary here, we can say that the stable carbocation will be secondary. So, the product will be based on that particular carbocation. Clear? It is about the Markovnikov's rule. Yes. Then about the anti-Markovnikov's rule, instead of carbocation mechanism, in case of anti-Markovnikov rule or Karash effect, it is based on the free radical mechanism, right? It will be based on the free radical mechanism. In this case also there will be two free radicals are forming. One is secondary and another one is primary. So based on the stability also we will get the product accordingly. Then but here why it is not by HCl or HI? What will be the reason? In case of HCl we can say that about the bond energy, right? This bond energy is very high. It cannot be broken by simple free radicals, right? In case of HCl. Then what about HI? When we are go through the mechanism of this particular reaction, we can say that in case of HCl or HBr or any hydrogen halide, there will be halogen free radicals are forming, right? If I am taking HBr here, I will be getting Br free radical, right? Br free radical. Similarly, if you are going through the HI molecule, it will be getting iodine free radical, right? Instead of attacking the double bond, these iodine free radical combine to form iodine molecule, right? This will be our iodine free radical. First, these iodine free radical will combine to form the iodine molecule. Instead of it is attacking to the alkene. Clear? That's why the reaction with HI does not happen in case of anti-Markovnikov rule. Clear? In case of HCl, it will be high bond energy. Is that clear? Okay, fine. Now let me move to the next type of addition reaction, that is about the addition of water, right? Addition of water. Now you may predict what will be the product. You can predict what will be the product just according to the Markovnikov rule. In case of water will be, what will be the electrophile there? It will be alcohol, right? It will be, the product will be alcohol. For example, if I am taking CH2 double bond CH2, that is my ethene molecule, in presence of concentrated sulfuric acid, this hydration will happen in presence of acidic only. So I am taking concentrated sulfuric acid here. We can split water molecule as H and OH, right? So according to Markovnikov rule, the negative part of the adding molecule, in case of water, the negative part will be the OH minus. It will go to the carbon and less number of hydrogen atom, right? But here the thing is that it will be a symmetrical alkene, right? It will be a symmetrical alkene, so we don't need to explain about the Markovnikovs here. The product will be CH3 CH2 COH, right? Our ethanol. Clear? It's about the reagent here. You have to mention about the reagent, that is about the concentrated sulfuric acid. If you are doing the symmetrical alkene, just add the OH minus to the. If you are taking the unsymmetrical alkenes, just like halogenation, we are doing the Markovnikov's rule here. As you can see over the next reaction, right? It's about 2-methyl propene, right? This will be H and OH, right? OH minus will go to the carbon containing lesser number of hydrogen atom. Here it will be 0 number of hydrogen is present, right? 0 number of hydrogen is present in the case of this carbon. So this OH will go to this side. So the product will be formed CH3C, CH3, CH3, OH, which means this is our tertiary butyl alcohol, right? This part is known as tertiary butyl. Having OH group is known as tertiary butyl alcohol. Is that clear? Okay, so far we discussed about the addition reactions, right? Starting from the addition of hydrogen, addition of halogen, addition of hydrogen bromide or hydrogen halide, the last one addition of water, right? So in this particular reaction, in case of addition reaction, Markovnikov rule and anti-Markovnikov rule is very important, right? You will get more applicational questions in the JEE Main exams. Okay, now let me move to the next type of reaction, that is the oxidation reaction, right? Oxidation reaction. So here I am treating the alkenes, right? I am treating the alkenes with cold dilute aqueous solution of potassium permanganate, right? KMnO4, potassium permanganate, cold aqueous solution of potassium permanganate. I will observe that it will get the product of vicinal diols. What will be the vicinal diols? Just like vicinal dihalides, two OH group will be present in to the adjacent carbon atoms, right? Two OH groups will be present at the adjacent carbon atom. These are known as vicinal diols, right? So aqueous solution in terms of oxidation in presence of KMnO4, right? It will get the product as CH2OH, CH2OH, that is ethane 1,2 diol, ethane 1,2 diol. Here it is observing that this particular reagent is known as Bayer's reagent. This is known as Bayer's reagent. So what you are observing here, in general the potassium permanganate is having the pink color, right? It is having the pink color. When you are adding this Bayer's reagent or the KMnO4 to the any of the alkene or any of the compound that is containing multiple bond, right? If you are adding towards the end, right? Towards the end, this pink color of the KMnO4 or the Bayer's reagent disappears, right? Disappearance of pink color occupies here. This pink color. So again, this particular reaction can also be used as a test for unsaturation. Test for unsaturation. In the previous case also we have seen one test for unsaturation, right? What was that? What was the first test for unsaturation? Just recall the thing. We have studied about the addition of halogens, right? If you are adding bromine in CCl4, generally bromine is having the additional color, right? After the reaction, it will disappear, which means that it is also used as a test for unsaturation. Just like that, here the pink color of the KMnO4 or the Bayer's reagent disappears. It is also used for the test for unsaturation, right? Test for unsaturation. The thing is that if you are doing this Bayer's reagent test with any of the alkenes, right, containing single bond compounds, it will not show the pink color disappearance or the positive result. So we can use to distinguish the alkenes from the alkenes or alkanes by using the Bayer's test. Is that clear? Okay, now let me talk about the very important, in examination point of view, it is very important. Many application questions will be asked from this particular topic only. That is about the ozonolysis, right? Ozonolysis of alkenes. Just from the name, we can identify that reagent will be ozone. One of the reagent will be ozone, right? So in case of alkenes, we are trying to add ozone. Then after that we are adding hydrolyzing, right? We are adding water in presence of zinc. So in the first step, right, I am taking ethene here, right? CH2 double bond CH2. What I am observing here, I am adding O3 molecule or ozone molecule, right? So the thing is that you will make this bond like this. CH2 CH2, right? Ozone will combine here like this. O3 molecule, right? So this is the intermediate that is known as ozonide, right? Ozonide. It will be highly unstable, right? It is highly unstable. So this is known as ozonide. Then after that, we are adding water molecule, right? Hydrolyzing in presence of zinc. Hydrolyzing in presence of zinc. What we are observing? This will break like this, right? So break like this to form 2 CHO molecule, right? 2 HCHO molecule, right? 2 HCHO molecule. This is known as formaldehyde, right? Formaldehyde. Then the next step, I am doing the ozonolysis of 2-methyl propane, right? 2-methyl propane. Just like I am adding ozone here, I will get the unstable ozonide here. You are observing here, just change the double bond here, then adding 3 oxygen molecules in between. You will get the ozonide molecule. Then finally, after hydrolysis with the zinc molecule, you will get 2 different carbonyl compounds, right? Here, I am breaking like this, right? But I am observing here, CH3C, CH3 double bond O. Make it as a carbonyl compound. Then here it will be HCHO, right? Formaldehyde as well as propanone, right? Propanone, or it is also known as acetone. Here it is formaldehyde, right? So in general, one more trick you have to keep in mind that if you are getting any of the alkene, right? If you are getting any of the alkene, for example, if you are getting any of the alkenes, right? Doing the ozonolysis in presence of zinc in H2O, right? What you have to do, just break the double bond, right? Just break the double bond. Then add oxygen, right? Add oxygen, make it as a carbonyl compound. So I will get that CH3CHO, right? CH3CHO. Again CH3CHO, which is our acetaldehyde, right? This will be the product of this particular reaction. The simple thing you have to note that if you are taking any of the alkene, just break from the double bonded side, right? Just break from the double bond side. Then add oxygen molecule, make it as a carbonyl compound, right? Either it will be ketone or aldehyde. Is that clear? Okay, you may get more questions from this particular topic. You can, question may be like that, predict the compounds as well as from the products also you can predict the alkene, right? What you have to do, just delete these oxygen, combine these compounds, make it as a double bond. Is that clear? Now let me move to the last type of reaction, that is about the polymerization reaction, right? Polymerization reaction, you may have idea about the monomers and polymers, right? If you are taking many of the monomer units, doing the polymerization, you will get the polymer unit. This is big molecule. So this is a process in which a large number of simple molecules known as monomers combine under suitable conditions to form a big molecule or giant molecule known as the polymer. This particular reaction is known as polymerization, and the simple molecules which is used in the polymerization is known as monomers, right? So here we are using ethene molecule, right? Ethene is our monomer here. I am adding, or I am doing the polymerization in presence of, if I am taking n number of CH2 double bond CH2 molecule or ethene molecule at a high pressure, right? 1500 to 2000 atmosphere pressure, in presence of oxygen at 200 degrees centigrade or 200 degrees Celsius temperature, I will get the polythene, right? Polythene. The plastic cover we are using, it is about the polythene, polyethylene. So this is the polymer of ethene. So it is known as polyethylene or polyethylene. Right? Polyethylene. Just like that, if you are taking propene molecule, right, n number of propene molecule, doing the polymerization at a high temperature and pressure, you will get the polypropene or polypropylene. Clear? This is very important as well as simple reaction. This is about the polymerization reaction. From this particular part, you may get the question from the what will be the monomer unit, like that. Is that clear? Okay, now let us practice some questions here. Here is the first question. Write the IUPAC names of the products obtained by the addition reactions of HBr to hex-1-ene. The reactant is given here, it is X1-ene. We have to add HBr in presence of peroxide as well as in absence of peroxide. What will be the product? This is hex-1-ene, right? 6-carbon compound containing double bond in the first carbon, first position, hex-1-ene. So I am adding HBr here, right? I am adding HBr here. First it is about the absence of peroxide, right? So I am just doing addition in which HBr is adding. What I am observing, this is my negative part, right? Br minus will be the negative part of this HBr. It will move to the carbon containing lesser number of hydrogen atom, right? Carbon containing lesser number of hydrogen atom. So I will get the product like this. CH3, CHBr, two bromo, right? 2 bromo hexane. 2 bromo hexane will be our products. The absence of peroxide here. The second case, if you are adding peroxide, it is about the anti-Markov-Nikov rule. It is about the anti-Markov-Nikov rule addition. So just like that. One bromohexane will be the major product in case of peroxide effect, right? Peroxide effect or the Karash effect. Okay, here is the next question. The product formed in the following reaction sequence is, an alkene is given here. The reagents which is given as HBr in presence of benzoyl peroxide, then alcoholic KOH. Two reactions are happening here. First, you have to add HBr in presence of peroxide to get the product. After that, you have to do the alcoholic KOH addition. What will be the product? Just let me know the answers in comments. Options are already given there. Okay, this will be the product, right? According to the anti-Markovnikov addition, we will get the product as 1-bromobutane, right? 1-bromobutane. So, we have already studied about the reactions, right? I mean preparation method from the alkyl halide. If you are doing the alcoholic KOH, right? If you are doing from the alkyl halide, what you are observing here is the dehydrohalogenation, right? Dehydrohalogenation. Here we are observing the Zaitsev rule, right? Zaitsev rule. CH3, CH2, CH double bond CH2, right? That will be our final product, which means option 2, right? Yes, option 2 will be the correct answer here. Is that clear? First, you have to apply the anti-Markovnikov rule here because of the presence of peroxide. Then the second one is about the Zaitsev rule here. We are treating the alkyl halide with the alcoholic KOH. Now let me move to the next question. When HCl is passed through propene in the presence of benzoyl peroxide, what it will gives? Do the reaction, find out the product, give me the name, whether it may be IUPAC name or the common name. Propene adding HCl in presence of benzoyl peroxide. Read the question carefully. Adding HCl in presence of peroxide, what will happen? Whether it follows anti-Markovnikov rule or Markovnikov rule. Okay, give me the answers. Try to solve this question. If you don't know the exact answer, also just give me the random guesses. 4 options are given, right? You can type it as 1, 2, 3 or 4. Propene, right? So we are just taking propene here. This is our propene. I'm adding HCl, right? HCl in presence of peroxide, right? Here it is given as benzoyl peroxide. So many of you may make the mistake like that. When you see peroxide, you will directly go to the when you see peroxide, you will directly go to the anti-Markovnikov rule, right? So when I was teaching about the anti-Markovnikov rule, I have already mentioned that it will applicable only for the HBr, right? It will applicable only for the HBr. So here it is given as HCl, right? So it does not follow the anti-Markovnikov rule. Here it will be Markovnikov rule only. Now let me give the, please give me the answer. What will be the product for me here? According to Markovnikov's addition. Okay, late ho gaya, right? Please watch the recorded session for the detailed class. Here I am practicing some question. We have studied about the chemical properties of alkenes, right? We have already studied about the addition reactions like addition of halogen, hydrogen, water and hydrogen halide. In the case of hydrogen halide, it will be about the Markovnikov and anti-Markovnikov addition. Then we have studied about the oxidation. Yes, oxidation and ozonolysis. In case of ozonolysis also, you will get more questions based on that particular topic only. Okay, fine. So, what will be the product here? Adding molecule, right? H plus and Cl minus. Negative part will go to the carbon containing less number of hydrogen atom. I am repeating once again. Cl minus will go to the carbon containing less number of hydrogen atom. Thus, the product will be CH3 CHCl, right? CH3 CHCl. Then CH3, right? Which means its IUPAC name will be 2-chloropropane, right? IUPAC name will be 2-chloropropane. Or I have already taught you about the IUPAC nomenclature of alkenes, right? Alkenes, if you any of the compound that contains CH3 twice bond, it will be named as iso group, right? Iso group. So I can call this as isopropyl chloride. Isopropyl chloride. This will be the common name. Isopropyl chloride. So here option 2 will be the correct answer. Is that clear? Okay. Here is the next question based on the ozonolysis concept. The total number of oxygen atoms present per molecule of the product formed by the ozonolysis of but2ene. You have to do the ozonolysis. Find out the total number of oxygen atom present per molecule. Present per molecule. What you have to do? First you have to write down the structure of but2ene, right? Second position there is a double bond CH3 CH double bond CH CH3. This is my but2ene, right? But2ene. What is the simple trick? You have to find out the ozonolysis product. What is the simple trick? Break from the double bond, right? Break from the double bond, add oxygen and make it as a carbonyl compound, right? So I am breaking from the double bond. Now I am adding oxygen to make it as a carbonyl compound. CH3 CHO, right? Plus again one more CH3 CHO, right? So this is our acetaldehyde, right? Acetaldehyde or ethanol. This will be the product. Acetaldehyde, 2 molecules of acetaldehyde or 2 molecules of ethanol. Our question is find out the number of oxygen atom, right? Find out the total number of oxygen atom present per molecule, which means if you are taking only one product, what will be the number of oxygen atom present in it? So here the product will be 1 acetaldehyde, right? So we are taking per molecule 1 oxygen atom is present here, right? Which means option 2 will be the correct answer. Is that clear? So while doing the ozonolysis, the reagent is very important, right? Ozone doing hydrolysis in presence of zinc metal, right? Ozonolysis adding ozone, it will produce in the ozonide. Then we are hydrolyzing in presence of zinc. Reagent is very important, right? Is that clear? Here is the next question which is based on the statement reaction. First statement, the peroxide effect, right? Peroxide effect is observed in the addition of HBr to unsymmetrical alkenes, right? But it does not observed in the addition of HCl, right? Read the assertional reason question. Assertion means peroxide effect is observed in the case of unsymmetrical alkenes of HBr in the unsymmetrical alkene, but it is not applicable in the case of HCl. Then reason it is given that HBr bond, right? HBr bond is cleaved by the free radical, whereas HCl bond is cleaved by the HCl bond is not cleaved by the free radical because of the more energy between them, right? More energy between them. I have already mentioned about the, while discussing about the anti-Markovnikov rule, right? Peroxide effect or Karash effect. It will applicable only in the case of HBr, not about the HCl and HE, right? HCl and HI. So this assertion is correct and reason is also correct. So we can say that this assertion and reason are correct and R is the correct explanation of A, which means option A will be the correct answer. Is that clear? Yes, correct. Here is the last question. This is the same question I have taken from the NCERT textbook. An alkene A that contains 3 CC sigma, CC single bond, 8 CH sigma bonds, 1 CC pi bond. A on ozonolysis gives 2 moles of an aldehyde. 2 moles of an aldehyde of molar mass 44 units. Write down the IUPAC name of A. Question is based on the ozonolysis concept. While reading the question, you may feel like that it's very heavy or very lengthy or difficult, but it is very easy. We have given an idea about the alkene molecule, right? How many bonds are present, how many sigma bonds are present, how many pi bonds are present, how many carbon atoms are present. Then on ozonolysis, it will producing 2 molecules of aldehyde, right? Having the molar mass of 44 units. First, you have to identify the alkene present here. What will be the answer? Okay, option is not given here. Right. What it is given here? 3 CC single bond, right? 3 CC single bond and 1 CC pi bond, which means that it may contain 4 carbon atoms, right? Are you able to understand? It contains 3 single bond, then 1 pi bond, right? So if you are observing here, one is CC single bond, right? CC single bond. Here it is 1. Then here it is again CC single bond, right? CC single bond. Then if you are considering this also, one of the bond will be sigma and another bond will be pi bond. So I can observe that there will be 1 CC sigma bond and 1 CC pi bond. So the bonds are balanced here, right? So we may have idea about that this particular alkene containing 4 carbon atoms, right? 4 carbon atoms. Now we have to balance the hydrogen atoms to maintain the hydrogen here. It will be CH3, CH, again CH, right? CH3, right? So this will be our alkene molecule. Now in order to confirm this particular reaction, you need to do the ozonolysis, right? You need to do the ozonolysis. Ozone in presence of, hydrolyzing in presence of zinc, right? What you have to do? Same. Breaking the bond, adding the oxygen, right? CH3CHO, 2 molecules of CH3CHO. In order to confirm, we have to identify the molecular mass, right? What will be the molar mass here? For 1 carbon, it will be 12 gram or 12 unit, right? Here I am taking 12 plus 12, 24, plus 3, 27, 28, plus 16, it will be 44, right? 44 unit. So, the question, according to the question, it is correct, right? It is observing by the ozonolysis, this particular alkene forming 2 moles of an aldehyde. 2 moles of an aldehyde having molar mass of 44 units. So we can confirm that the particular alkene will be this one. You need to identify the IUPAC name. What will be the IUPAC name of this particular alkene? 4 carbon compound. What is the position of double bond here? 2, right? So the IUPAC name of this particular compound is but2e, right? but2e. Is that clear? Okay, fine. So far we have discussed successfully discussed about the part of alkenes, right? The last class we have studied about the IUPAC nomenclature, isomerism as well as preparation method of alkenes. Then in this class we have covered about the chemical properties as well as physical properties. Like just like alkenes, we have covered the alkenes also. If you have any doubt, you can ask now. Otherwise, we can wind up the session for today. Again, there is a gentle reminder about the AATS. JEE Main session 2 is coming, right? Only few days are remaining. So the link will be provided in the description. You can take the link and enroll the first. You will get 50% off by using the YouTube 50 off code. So it will be really helpful. For the last time preparation, you can take the mock test also for the JEE Main session 2 and as well as JEE Advanced. Okay, I hope it was clear for everyone. Now in the next session, in the next class, in the same time from 5 to 6, I will be coming back with the next type of hydrocarbon, that is about the alkenes containing triple bond. We will be starting from the nomenclature as well as isomerism of that particular alkenes. So make sure that you will be joining me with the same class by the 5 to 6, right? The regular time will be 5 to 6. If you have any urgency, we will extend the time also. Okay, many of the students are asking for the PDF also. You can join our Telegram channel, that is Infinity Learn JEE Telegram channel. You will get the session PDF after each class. Okay, clear? Fine. So if you really like the session, just hit the like button, subscribe our channel and share this particular session to your friends also. So thank you so much all of you. Bye bye and take care. See you in the next session.